Hello students, welcome to IMS GATE Academy, and IMS GATE Academy presents a foundation course for engineering mechanics, particularly for GATE 24 and 25 students. Okay, now as we are at the end of our foundation course, tomorrow was the last session, and however we have covered so many statics sessions as well as the dynamic sessions as well. Okay, right. Now today's session is all about dynamics of rigid bodies. Dynamics of particles we have studied, in that kinematics of particles and kinetics of particles we have studied, and we have solved some problems as well, right? Now today's session is dynamics of rigid bodies. Now here in the dynamics of rigid bodies, as you know that, 1 minute guys. Right. Dynamics of rigid bodies. For the dynamics of rigid bodies, so again here we have to study kinematics of rigid bodies, kinetics of rigid bodies. Rigid bodies here we have considered that particle and rigid body I have differentiated earlier. What is particle? So the size and shape of the body will not affect the motion of the body, then it is considered as a particle, right? Now body, rigid body, whenever the size and shape of the body influence the motion of the body, when it is in motion, then it is considered as a rigid body, right? Now here we are studying the motion of rigid body, right? So now here we have two types of dynamics, that is the kinematics of rigid bodies and kinetics of rigid bodies, right? Now dynamics of rigid bodies, our topic is dynamics of rigid bodies. All right guys, now in this dynamics of rigid bodies, okay, we have to study both kinematics as well as the kinetics, both we have to study, right? Now here rigid body, what is rigid body, right? This we have already discussed, that the size and shape of the body influence the motion of the body, then it is considered as a rigid body. All right, right. Now here, so in dynamics of rigid bodies we have two, that is kinematics of rigid body, kinematics of rigid bodies, and second one is kinetics of rigid bodies. Kinetics of rigid bodies. Kinetics of rigid bodies. All right, right. Now here, what is kinematics and kinetics? This I have already differentiate. What is that? If you consider the force which caused the motion, so then it is come under kinetics. Without considering the force which caused the motion on the body, that is come under kinematics, isn't it guys? Right. Now suppose say that if you push one body and it is in motion, it creates some motion, the force creates some motion on the body, right? If you are not considering the force which caused the motion of the body, then it is considered as a kinematics of rigid bodies, right? Right. If you consider the force, then it is considered as a kinetics of rigid body, right? Here I will highlight that in a simple word, okay, right? Now without force, and also here with the force. All right guys, right? Now here, so we will highlight today is kinematics of rigid bodies, right? Now, so in rigid bodies, when they are in motion, if you take any particle in the rigid body when it is in motion, so all the particles having different displacement, different velocity, and also different acceleration. But in case of particles, kinematics of particles, what happen? So in kinematics of particles, what happen? Displacement, velocity, as well as the acceleration, all are at every particle. We are considering like that and we are solving the problems. But here in rigid bodies it is not possible, right? Now suppose say that in rigid bodies, suppose say this is a one rigid body, right? In this rigid body, if I consider these particles, say that this is a particle 1, particle 2, particle 3, like that. So now what happened now? So displacement, velocity and acceleration for the particle 1 and this is S1, V1, A1. Similarly, S2, V2 and A2, say that it is second particle. Now, displacement of a third particle, velocity of third particle, acceleration of the third particle, right? So, now all these are different. Okay, so now if you take at any particle, the velocity, acceleration, displacement are going to be different in the rigid bodies. But where in case of particle, what happen? If you take a particle, then what happen? Na? So the particle having the, all particles having the same velocity. That means here S1 equal to S2 equal to S3. V1 equal to V2 equal to V3 and A1 equal to A2 equal to A3 when we study about the particle, but here it is completely different. All right guys, completely different. So now here in rigid bodies, each and every particle having its own independent velocity, independent acceleration as well as the displacement. So we are considering like that and we are going to study, right? And one more thing here I would like to differentiate that guys, right? Now here we have studied, we have a motions of three motions. What is that? Translation motion, rotation and also general motion. Three motions we have. So in translation motion again we have rectilinear motion and curvilinear motion. So now if you study the translation motion for the particle as with considering forces, without considering forces is come under kinematics of particles and kinetics of particles, right? If you study the motion of the body, right, that is come under rotation motion as well as the general motion, right? Now studying about the translation is come under particles, right? So studying about the bodies with considering, without considering is come under kinematics of rigid bodies and kinetics of what is that? Rigid bodies. All right guys, hope you understand everybody, hope you understand, right? Now why we are not considering that particle means here rigid body means here all the particles having different velocities, acceleration as well as the displacement, right? Now here we are going to study the kinematics of kinematics of rigid bodies. First motion is rotational motion. Rotational motion, right? Rotational motion, right? Now here in this I would like to highlight this definition. I have already given this definition I have already given you. What is that? When a body move in a circular path, if all velocities of the particles are different and paths are same, then it is considered as a rotational motion. Okay, so all the particles path is similar, but velocity of the particles in the body is going to be different. That is come under rotational motion, right? So this is what we have already described. Now let us move for how to study the motion variables in the rotational motion. Okay, how to study the rotational motion. Suppose say that how to study the motion variables in the rotational motion, right? So rotational motion means when the body is moving in a circular path or the body moves about its axis, right? Then it is considered as a rotational motion, right? Now here find the motion variables in rotational motion. 1 minute guys. Motion variables. Motion variables in rotational motion. Rotational motion. All right. What are that? What are the motion variables? Here we have two types of motion variables: angular motion variable and linear motion variable. Okay. Now here in rotational motion we have two types of motion variables. Two types of motion variables. So what are they? What are they? What are the two types of motion variables? Right. Now let me describe you that. First one is the angular motion variables. Angular motion variables. All right guys, angular motion variables. And second one is linear motion variables. linear motion variables. Linear motion variables. All right, right. Now we will highlight one by one. Okay, in angular motion variables, what are there and what are the linear motion variables? Angular motion variables means angular velocity, angular displacement, angular velocity and angular acceleration. Motion variables will not be changed. The only thing is we will study in angularly. That means in a rotational motion we are studying, that is why they are come under angular acceleration, angular displacement and angular velocity. I hope everybody understand. I hope everybody understand, right? Now first I'll highlight that angular motion variables. I just highlight that angular motion variables. First category, angular motion variables. Angular motion variables. What are the angular motion variables? When a body in a rotation motion, then we will study the motion variables two types. One is the angular motion variables, another one is the linear motion variables, right? Now first we will highlight that angular motion variables, right? So first is angular displacement. Angular displacement, and second one is angular velocity, and third one is angular acceleration. All right guys, these are the three types of motion variables which we have in the rotation motion, particularly in angular motion variables. Okay, so in rotation motion, in order to study the motion variables, we have two types. One is the angular motion variables, and second one is the linear motion variables. Now here I am highlighting that first angular motion variables, that is angular displacement, angular velocity and angular acceleration, right? Now here see guys, actually displacement we have indicated with S, velocity we indicated with V, acceleration we indicated with A, where in case of translation motion, but here it is angular. That is why I am just changing the letters. That angular displacement I am taking it as theta, right? So angular velocity I am taking it as omega, right? Now angular acceleration I will take it as alpha. What do you say guys? Okay, so based on that we can differentiate that motion variables in between the translation motion as well as the rotation motion. All right guys, now we'll consider a body which is in rotation motion. Okay, and then we will define angular displacement, angular velocity and angular acceleration. These parameters or these variables can be studied when the body is in rotation motion, right? So in order to understand the displacement, velocity and acceleration, and we need to consider a body which is in rotation motion, then only it is possible to observe the displacement, angular velocity and angular acceleration, isn't it guys? Now let us move and consider a body which is see, suppose I am taking a shape, right? I am taking a shape. I am considering a body. Right. Now which is hinged at this end, For that I am taking again a shape which is hinged at this end. Right. Which is hinged at this end like this. and this is hinged, and this point I am taking it as O. I am taking this point as a O. Alright guys, right? I am taking one body and which is hinged at point O, which is hinged at point O. Okay. Now I hope it is not visible properly to you guys. Okay. Right. I have taken wrong colors. Right. Now here it is hinged at this point. Alright. Now it is visible. Right. Huh. Right. It is hinged at this position. Alright. Now if I apply an anti-clockwise moment over here, if I apply an anti-clockwise moment here, so here I am considering two particles in this body. Two particles I am considering on this body. Say this is a particle 1 and say this is, I am taking it as a particle 2. Okay. So after that I am taking again, if I apply anti-clockwise moment, after some time now I am considering a two particles over here. Okay. So on this body which is hinged at this point, if I apply an anti-clockwise motion here, if I apply an anti-clockwise motion here, then after t time, then what happened? After t time, it is a initial position. It is a initial position, right? Now here it is a final position. Final position. All right, guys, right? This is after t time. After t time. All right. After t time, so it is going to be a reach to this position, right? Now the angle between the initial position to final position, I am taking it as theta. The angle between the initial position to final position, I am taking theta. All right. So now these particles I am taking again because these are very nearer, cannot be differentiated properly. Particle 1 and say particle 2, right? Now the angle between the initial position and final position is theta, right? Now, so after t time, then my one particle becomes it as a 1 dash, right? My second particle become as a 2 dash. My second particle become as a 2 dash, isn't it, guys? Right? Now here these are going to be followed the path. First followed the path is like this, first particle, and second particle followed the path is like this after t time. Okay. So after t time, first particle follows the path like this and second particle follow the path like this. All right. Like this, isn't it, guys? Right? So now here it is in the body is in rotation motion and it is a fixed axis rotation, right? It is a axis of rotation, that means or point of rotation. It is axis of rotation, right? Now the body is in rotation motion. So if the body is in rotation motion like this, then how we are going to study our motion variables, that is angular displacement, angular velocity as well as the angular acceleration, how we are going to study this, that is what the important thing over here. All right, guys, right? Now here first is angular displacement. First motion variable is angular displacement. First motion variable is angular displacement. Angular displacement, right? Angular displacement. All right, guys, right? Now here I just highlight this. So angular displacement we will indicate with theta, right? Now here can I show you that where is angular displacement? So this particle angular displacement is theta. Particle 1 angular displacement is theta. Don't consider, my boys, don't consider that this is linear displacement, right? Now the particles moved in a angular, right? So the distance 1 to 1 dash is a linear, right? I'm not talking about that, but here I'm talking about the angle between the 1 to 1 dash is theta. That is the angular displacement, right? Similarly, the angular displacement of second particle is also theta. In t time, how much my particle 1 having the angular displacement, the same angular displacement is also had by the second particle in t time. Are you getting my point? Now in simple words, I can define my theta. It is the angle between initial and final positions. All right, it is the angle between initial and final position, right? Angular displacement can be written as, it's a angle between initial and final position. Initial and final position. All right, guys, it is the angle between initial and final position. Clear, everybody? Right. This is the angle by which the body rotated in t time. We can also define like this. So first definition, it is the angular displacement is the angle which is made by the body in t time during rotation, right? It is angle made by the rotating body in t time, right? Now, so here we can also define this. It is the angle by which the body, it is an angle which is made by it is an angle which is made by rotated body in t time. Rotated body in t time. In t time. Yes, guys, this is what. Okay. Okay, right. Here I would like to highlight one thing, guys. The angular displacement in pure rotation motion is equal for every particle. What do you say? The angular displacement theta is equal for every particle in the true rotation of the body. Okay, that means when the body is in true rotation motion, then all the angular displacement of the particles is same. Do you understand? Right. Now, so let me say, suppose say that I am taking 3 point here. Let us see that I am taking a 0.3 here, right? Now 0.3 here, right? Now after some time, my point will reach over here. That is 3 dash. Right? Now here it is gonna be it is also come like that, right? So now angular displacement of third particle is also theta. So I would like to conclude that when your body is in pure rotation motion, here my body is in pure rotation motion, right? Whenever it is in pre-rotation motion, then what happen na? So whatever the angular displacement is taking place, that is equal for every particles in the body. That is what I would like to highlight, right? Now I'll write the same point here. If your body is in pure rotation, if a body in pure rotation, all the particles in the body, have same angular displacement. same angular displacement. All right, guys, right? I hope everybody understand, right? Now, angular displacement for particle 1 equal to angular displacement particle 2, right? Now, here angular displacement for particle 1, angular displacement for particle 1 is equal to, it is angular displacement of particle 2. Angular displacement of particle 2. All right, guys, right? Now, here can I write it is theta 1 is equal to theta 2 is equal to theta? Yes, guys. Theta 1 is equal to theta 2 is equal to theta 3. Why? Because angular displacement in pure rotation motion in the body is equal for every particle in the body. All right, guys, that is what I have highlighted, right? Now, here we have seen that angular displacement, that is theta, is same for every particle in t time. All right, right. Now, let us move for the angular velocity. Second motion variable is angular velocity. Angular velocity. Angular velocity omega we have considered, isn't it, guys? Omega we have considered. All right. Now, let me go for the angular velocity. Let me go for the angular velocity. Right. Now, the rate of change of angular displacement with respect to time called angular velocity, isn't it? The rate of change of angular displacement with respect to time is come under angular velocity. All right, right. Now, here see the rate of, the rate of change of angular displacement the rate of change of angular displacement with respect to time called angular velocity. Called angular velocity, isn't it? Right. Now, can I write my angular velocity like this, guys? Can I write my angular velocity? Right. Now, here W is equal to, it is going to be a d theta by dt. Right. Now, the change in the angular displacement with respect to time is called, angular velocity, right? Now, here also the angular velocity is also similar for every particle, right? Can I say that like that? So, that means, see, whatever the angular velocity having my first particle, the same angular velocity by second and third particle also. That means, whenever angular displacement is equal to with respect to time, for t time, t is same for every particle, theta is same for every particle, so that our W is equal to, see, our omega is equal to, so if I take that W1, that is d theta 1 by dt1, right? So, now time required for first particle angular displacement next. So, here what I am trying to tell you, every particle time is same, displacement is also same, so that for every particle angular velocity is also same, right? That is what I would like to conclude. Clear, everybody? Right. Now, here let's see that. Suppose, say that excuse me, d theta 1, dt1, right. Similarly, W2 is equal to d theta 2 is divided by dt2 for every particle in the body every particle in the body, theta and t are same, so that what happen? So whenever angular displacement and time required for the angular displacement is same for every particle, obviously angular velocity for every particle is also same. That is what I would like to conclude. Yes guys, so every particle having the same angular velocity if they have same angular acceleration with respect to time. All right, now here I will highlight that here one thing, that is equal to W1 equal to W2 equal to W3. Whenever a body is in pure rotation motion, then on the particles in the body having the same angular velocity. That is what I would like to conclude. Why? Because so angular displacement is same and with respect to time is same for every particle, so that my angular velocity is also same for every particle. Clear everybody guys? Hope you understand. Right? Now let us move for angular acceleration. All right. Third motion variable is, angular acceleration. All right guys, angular acceleration we indicate with alpha. All right, angular acceleration is alpha, isn't it guys? Angular acceleration is alpha. Now how can we define? The rate of change in angular velocity with respect to time is considered as a angular acceleration, right? Now the rate of change of angular velocity with respect to time, I'm sorry, I'll write full form because it's a foundation course now. Everything should be in the unique, right? With respect to time, called angular acceleration. Right? Angular acceleration. Right? How can I write my angular acceleration? Rate of change of angular velocity with respect to time, alpha is equal to, it is dw by dt, right? dw by dt, isn't it guys? dw by dt, right? If dw by dt, that means w is same for every particle, t is also same for every particle, so that angular acceleration is also same for every particle when a body is in pure rotation, right? If you consider some particles in the body, if the body is in completely or pure rotation motion, in that case what happen na? Angular displacement, angular velocity and angular acceleration all are same for every particle. That is what I would like to conclude. Why? Because angular displacement theta is same for every particle with respect to time. That means in t time, how much angle all particles are moved is theta, right? Similarly, if I differentiate that with respect to time, I will get velocity. If theta is same for every particle, so that my omega, that means angular velocity is also same for every particle, right? Similarly, if angular velocity is same for every particle with respect to time, in t time angular velocity is same for every particle, then my angular acceleration is also same for every particle, isn't it? So right now here I will write it as, alpha 1 is equal to alpha 2 is equal to alpha 3 and so on. Since I can write it as, right, because omega 1 is equal to omega 2 is equal to, omega 3 and so on. Right? Now T also same. same. So for time required for rotate one particle is same, time rotate to second particle is also same, time required for rotate three particles is also same. That is why angular acceleration is also same, right? In simple words, I will conclude guys, whenever a body is in pure rotation motion, all the particles having same angular velocity, angular displacement, angular velocity and angular acceleration. This is what I would like to conclude. This is what we have proved as well now. So by using this example, we have proved already, right? So now see this, theta cm is for every particle in t time. That is why if I differentiate my theta with respect to time, I am going to get angular velocity. If theta is same for every particle, so that angular velocity is also same for every particle. Similarly, if angular velocity for every particle is same, so that my angular acceleration is also same for every particle. If W1 equal to W2 equal to W3, so that alpha 1 equal to alpha 2 equal to alpha 3. Whenever T1 equal to T2, theta 1 equal to theta 2 equal to theta 3 in T time. Okay, that is what I have highlighted and I have proved that. Alright guys, right? Now here let us go for angular acceleration, and angular acceleration is also same for every particle, right? Here I will write a point. If a body is in pure rotation, right? If a body in pure rotation, if a body in pure rotation such that all the particles in the body, one minute guys, all the particles in the body have same angular velocity, sorry, first displacement, no? Displacement, velocity and acceleration. Isn't it guys? All right. Right, this is what happening in this showcase, right? Now let us plot some basic equations. Before that, we'll add one more slide, right? Some basic equation we just follow, right? What are the basic equation we have in translation motion, guys? What is the basic equation we have a translation motion, right? So now let us go for in translation motion basic equations. Basic motion equations in translation. I just compare guys. I just compare and give you the, you know, so in comparison way I will give you such that you can remember very easily. All right, right. Basic equations of motion, when body in rotation, in translation, not body required, in rotation we will say, in rotation. All right. Right guys, now what are the basic equations? Now let us go for that, right? First basic equation is V equal to U plus AT. All right, next is equal to S equal to UT plus half AT square, isn't it? Right, now V square minus U square is equal to, you know, it is going to be a 2AS. As we know that U is the initial velocity of the body, V is the final velocity of the body, S is a displacement, T is a time and A is the acceleration. So these are the three basic equations of the motion in translation, right? Now similarly, we plot the equations in this one. Okay. Now very simple, guys, very simple, right? So now in place of v, I will take omega is the final velocity, angular velocity is equal to omega naught plus angular displacement and time. Done, right? Now s, displacement, angular displacement is theta. Theta is equal to s w naught into t, right, plus half into alpha t square, isn't it, guys, right? So displacement, angular displacement, final velocity, angular final velocity, w naught we have not discussed. It's a simple word, simple letter that v naught indicates that initial angular velocity. That's it, initial angular velocity, right? Now here another thing is w square minus w naught square is equal to 2 acceleration. Acceleration is alpha, s is theta, 2 alpha theta. That's it. So where here I will write it is here. I will write the terminology. I will write the terminology. That is final angular velocity. Final angular velocity. Right. Now w naught is the initial angular velocity. So theta is the angular displacement. Right. Now next is w we have defined. Alpha is the angular acceleration. Isn't it, guys? I hope everybody understand. I hope everybody understand. Here time is t is time. Time is common for both cases. Right here I can write here. Here v is final velocity. V is final velocity. Right. Now u is initial velocity. U is initial velocity. Right. S is displacement. S is displacement. And a is the acceleration. All right. T is same for both cases. Right. Now I hope everybody understand this. I hope everybody understand this. Yes, guys. Yes, guys. Please do respond. Please do respond. All right. Right. Now hope everybody understand. We will see some problems related to this angular velocity. Yes, guys. Right. Have a look on this. Have a look on this. Not this. We will go for another question. It is related to linear velocity. Right. Try to solve. Try to solve. I will give you 1 minute time. Right, guys. Now let me see that what are the things are given, right? A flywheel starts from rest and revolves with an acceleration of 0.5 radians per second square. And what will be the angular velocity and angular displacement after 10 seconds? After 10 seconds. This is what we are supposed to calculate, right? Now here what is given? Angular acceleration is given. That is, first you write given data. Whenever you encounter with a question, guys, then immediately you write given data. Angular acceleration 5 radian per second square. Right, guys, I just go back because I didn't discuss the units at all. Okay, and here, so here theta in radians, guys. Theta is in radians, right? Right. Here angular velocity, theta is in radians and t is in seconds. Right? Try to understand. Angular velocity, radian per second. Right? Where we'll get meters per second. Where we'll get linear displacement is in meters, but here in radians. All right. Right. Now similarly, angular acceleration. Now here, so what are the units for this? Angular velocity. Angular velocity units. Angular velocity units or radian per second. Na? So radian per second is divided by second again, right? Now I can write this fellow radians per second square, where we will get meters per second square. Clear everybody, guys? Clear? So try to understand. Right. Now here let us go to our problem. Then you were very clear about the units, na? Now we will solve a problem. Right. Let's have a look on this. Right. Radius is given, angular acceleration is given, and we need to find angular velocity. What angular velocity? So either initial angular velocity and final angular velocity. We have a two now, right? Now here read the problem very carefully. A flywheel starts from rest. The flywheel starts from rest. That means the initial velocity of the flywheel is 0. The initial velocity of the flywheel is 0. It is starts from rest. Right? Now here W naught equal to 0. Right? W naught equal to 0. Right? Next. And here we need to find angular velocity W. Angular displacement is theta. We have to find, and we know that t is equal to given 10 seconds. T equal to given 10 seconds. Right, guys? Now use the basic equation and try to find out the, what is that? We need to find angular final velocity and angular displacement. Right, try to solve, guys. Try to solve, everybody. Try to solve. Right, now here I will solve. Have a look on this. We have a basic questions now. So in these questions, see, basic equations, sorry. Right. So in these three equations, we can use any one. Right? We can use any one. See, we know that we require this. We know this. We know this. Right? Now substitute that equation. Right. Now W is equal to W naught plus, you plus it alpha t, right? Now W is equal to, W naught is 0 plus alpha is 0.5 radians per second square into this fellow is 10, such that my W is equal to, it is 0.5 into 10, such that angular velocity, final angular velocity is 5 radian per second. So do remember very careful about the equations. Now we got that angular velocity W equal to 5 radian per second. Everybody got this, guys? Please do respond. Right. Now let's go for taking the theta. Right. What is that angular displacement we require? So for angular displacement, so what is that theta we require? So theta, can I write this? So W naught t plus half alpha t square. S equal to ut plus half at square. Right. So displacement equal to initial angular velocity into t plus half into angular acceleration into t square. That's it. Clear everybody? Right. Now substitute all the values. So this is W naught is 0 into T plus half into alpha is how much, guys? Alpha is 5 radians. Oh my god, it is 0.5. I'm sorry, it is 0.5. But here I have substituted correct only, but I have written it is wrong. Okay. So now let me correct this. .5 radian per second square. All right. Right. Now here 0.5 radian per second square, and here T is 10 seconds. Right. T is 10 seconds. That is 10 square. All right, such that my theta is equal to, it is half into, so 0.5 into 100, such that theta is going to be, I am going to get theta is equal to so 0.5 is 50 by 2 25 radians. 25 radians. Clear everybody, guys? Clear everybody? So try to solve, everybody try to solve and have a look on this, how I have solved the problem. Have a look on this. Right. Now we will go for another question. Have a look on this. Try to solve, guys. Now have a look on this, and so I try to solve this problem. What is given? A flywheel increases its speed from 45 rpm to 90 rpm in 30 seconds. Right. Now find the angular acceleration of the wheel in radian per second square. Right. In radian per second square. Here rpm is given. Right. Initial rpm is given, final rpm is given. That means initially it is rotated with a 45 rpm. After 30 seconds, it reaches to 90 rpm. In that case, the velocity is going to be changed. Na? Initially, it is 45. Now, 45 rpm. Whereas, if you go for after 30 seconds, then it is become 90 rpm. What does it mean? So, some force is applied such that acceleration got increased. Now, we have to find the angular acceleration angular acceleration of the wheel in radian per second square. Right? First, write given data, guys. First, write given data. N naught is equal to, let me write it properly. N naught initial rpm is equal to, it is 45 rpm. Right. Now here N final or N1 you can say, N we can say, right. It is gonna be a 90 rpm and T is given, that is 30 seconds. Right. Now we have to find angular acceleration alpha. This is what my given data. This is what my given data. Right. Now I need to find angular acceleration. Right. So what is angular acceleration? The rate of change of angular velocity with respect to time is called angular acceleration. Right. The rate of change of angular acceleration, the rate of change of angular velocity with respect to time, then we are going to get it as angular acceleration. Clear everybody, guys? Right. Now we require angular velocity. We require angular velocity. Clear everybody? We require angular velocity. Now let us calculate the angular velocity. Right. Now see, how can we calculate angular velocity? Right. Now here W naught is equal to 2 pi n naught by 60, right? Now I got my initial angular velocity. Why? Because guys, here they gave in terms of RPM. Now if you know the flywheel RPM, how can you calculate angular velocity? That is 2 pi n by 60 na. Angular velocity equal to 2 pi n by 60 na. Everybody knows na, right guys? Right guys? Try to understand, right? Right. Now here let us substitute that. Then 2 pi n naught is 45 is divided by 60. We'll keep like this. Now final angular velocity 2 pi n is divided by 60, such that I am going to get it is 2 pi n is 90 rpm is divided by 60 is divided by 60, final angular velocity, right? Now I know initial angular velocity, I know final angular velocity, then I know the time, then what equation I can use, right? Now here can I write like this, my equation, initial angular velocity is equal to final angular velocity is equal to initial angular velocity into t plus ut plus half u plus half 8. So no, I'm sorry, u plus 80, that's it. AT means here alpha na, alpha t, isn't it guys? Now I know this fellow, and I know the time also. Then you just calculate that, you just substitute all the values, then you are going to get, so right. Now in order to simplify that, so W equal to it is 2 pi n is 90 I guess, right? 2 pi n by 60 is equal to, it is 2 pi n 45 is divided by 60 plus alpha into t is 30 seconds, right? Now it is going to be a 942 radian per second. Oh, no required, not radian per second. However, it is radian per second, but here in calculations it's not required. Right, if I do that, I'll get 9.42, and this I'll get it is a 4.71. So try to calculate that plus alpha into 30, right? So now from there, by this equation, if I solve that, all known values, only unknown is alpha, angular acceleration, right? Find out that and let me know. Find out and let me know. Now it is going to be a 0.15 seconds. 0.15 radian per second square. 0.15 radian per second square you will get. All right, guys. All right. So hope you everybody understand. Right. Have a look on that, how I have solved the problem. Right. Try to solve this problem, guys. Try to solve this problem. Right. Let me have a look on this. Have a look on this problem. Right. What is given in the problem? Right. Now the question for angular displacement of a body moving on a circular path. Right, guys? It is moving in a circular path. That means rotation motion. Right. Given by angular displacement is a function of time, guys. Angular displacement is a function of time. Now where theta is now it is not 8, guys, it is theta actually. Theta is in radians and t is in seconds. Now find the angular velocity, that is w we need to find, and displacement, that is theta, and acceleration alpha we need to find at t equal to 2 seconds. Okay. So if t equal to 2 seconds, after 2 seconds, that means the body is already moving in a circular path from initial position and the displacement is given in terms of t, right? Now after 2 seconds, what is the angular displacement, what is the angular velocity, what is the angular acceleration? So we need to find all these three terminology. All right, guys, right? Now here, so it's a very simple, guys, right? So have a look on this, right? So here theta is given, it is gonna be a 2t cube plus 0.5, right? Now, so what is my angular velocity? What is my angular velocity? Right? Now, so if we require displacement at after 2 seconds, now directly we will find that at t equal to 2 seconds. At t equal to 2 seconds, right? Now here what happened now? So now theta is equal to substitute t in place of t cube plus 0.5. That is going to be a, it is 8 into 2 is 16 plus 0.5. 16.5 radians is a angular displacement. All right. We got theta, but this is over. Now here we need to find angular velocity, right? Now let's move for angular velocity. W is equal to, can I write it is d theta by dt, d theta by dt, angular velocity, right? Now I'll write full form. Angular velocity, W. So now here I can write my angular velocity W is equal to, it is d theta by dt, right? D theta by dt, right? Now here d of dt is equal to, it is going to be a 2t cube plus 0.5. 2t cube plus 0.5, right? Now solve this, differentiate that. If I differentiate that, what I'm going to get? Now if I differentiate this, here 6 into t square plus 0, right? Now here my angular velocity is 6t square at t equal to 2. Then what happened? Angular velocity is equal to, it is W is equal to 6 into 2 square, such that it is going to be a, so what happened? It is 4 into 6, 24 radian per second. 24 radian per second I am going to get. Clear everybody, guys? Clear everybody? Right. Now let us move for angular acceleration. Right. Now here angular acceleration, right, alpha, right? How can I write my alpha? Right, as I know the equation that alpha is equal to, it is dw by dt, right? dw by dt. But here you need to write your angular velocity in terms of t. Then only it is possible to get the angular acceleration, isn't it, guys? Right? Now here what is our angular velocity? Angular velocity, see that here in terms of t, my angular velocity is 6t square, right? 6t square, right? Now here I'll substitute the same here, d of dt, right? Now it is going to be a 6t square. 6t square, isn't it, guys? Now let us see, have a look on this. See how I got. So if I differentiate my angular displacement with respect to time, then I am going to get my angular velocity, right? Now if I differentiate my angular velocity with respect to time, then I am going to get my angular acceleration, right? Now here, so angular velocity I got like this. Now here if I differentiate that, I will write here only, it is going to be a 12t, right? Now at t equal to 2, at t equal to 2, right? Now here at t equal to 2, then what happened? So what is my equation, right? My f alpha is equal to, it is 12t, right? Now here it is 12 into 2 such that it is going to be a 24 radian per second square. Clear everybody, guys, right? Now my angular acceleration equal to angular velocity, my angular displacement is 16.5 radians. Like that you are supposed to solve. If your path is given, if the displacement is given in terms of in the function of time, then how you are going to solve the question, right? Now displacement, that is velocity equal to displacement divided by dt. That means differentiate the displacement with respect to time, then you are getting a velocity, right? Differentiate velocity with respect to time, then you are going to get acceleration, right? Clear everybody, guys? I hope everybody understand. I hope everybody understand, right? I hope I have simplified and clear cut idea about the when the body is in rotation motion, right? So rigid body rotation motion, when the body is in rotation motion, all the particles are having same angular displacement, velocity, acceleration is same for all particles. When it is in linear, it is different. All right, guys. Now that we have proved and we have solved some problems as well, right? Now this is what the session today, and now let me introduce you, our success stories of IMS GATE Academy, right? That is, GATE success toppers for 2023. That is, All India rank 4, mechanical 4, and instrumentation it is 4, and All India rank of CS, that is computer science is 4, production and industrial engineering 4 rank, and All India 7th rank in ES, All India 7th rank in mechanical, right? Now All India 9th rank in mechanical, industrial and production engineering again 10th rank. Now All India EC 17th rank, EEE 15th rank, and civil engineering 19th rank. Right, guys? All these successful people are enrolled with IMS GATE Academy, and they have acquired the knowledge in order to get the ranks and fit in this frame, right? Now here there are many ranks also below the 100. So now here what I would like to highlight here, guys, please enroll with IMS GATE Academy. If you require any counseling, then some following numbers are floating in the bottom. You just call to them. Our team come and motivate you and giving counseling to you in order to take the GATE coaching. And these foundation courses are for all branches, for some important subjects we have started, right? So by watching this foundation course, if you join with us, so that we will go for much more depth and much more question solving in order to make you perfect in cracking the GATE 24 and 25, right? So if you learn the things and if you acquire the knowledge through this session, then try to spread to your friends, right? Now let us go for what IMS is providing the features, right? Now if you enroll with us, then what happened now? 800 live sessions with live interactions, okay? Live sessions will give 130 plus online test series we will provide, and 20 to 30 theory books and exercise book. That means 20 to 30 hard copies of books we will give you. In that books, what happened now? Theoretical conceptual things are explained, and also practice problems given. In exercise books, completely it is problems and solutions with the different levels, level 1, level 2, level 3 as well, right? Now here 120 one-to-one personalized session, mentorship sessions, that is, not 120, 12. That means if the students directly communicate with the faculty with the respective subject, and you may discuss with the strategies how to prepare for that particular subject, and also you can get some confidence level enhancement through the sessions. That is what. So here, in order to inject the confidential levels and enhance the confidence levels during preparation with our best strategies, we are giving this one-to-one personalization mentorship for every student, right? next revise sessions and much more, right? Now here admissions are going, guys, admissions are going. You just call to the following numbers and get counseled nearby. If you have any office, then you can go and communicate with the faculty and our team, so that you will be able to understand what content and what best faculty we have in IMS GATE Academy. All right, now the session ends today. Thank you all of you. Thank you very much for your patient listen. So that's all. Tomorrow we will discuss about kinetics of rigid bodies. All right, thank you all.